Alright, so today we're talking about graphing, quadratic functions, basic ones, pretty easy. There's a couple different ways to do it. I'm going to show you one way. I may talk about another way, but the way I do it, I think is easier of the two. Up to you. You ready? Okay, we're good?
Yep.
Okay, second thing we're going to do today is we'll talk about the difference between vertex and standard form. We're actually doing it in the opposite order. We'll talk about standard vertex first, then we'll talk about graphing. So, there's two forms you write quadratics in. Both of them use a vertex and an axis of symmetry. When we draw a quadratic, it looks like a parabola. It almost looks like a U. We talked about parabolas yesterday a little bit. You did them in geometry, right? The parabolas we deal with will either be opening down or opening up. I believe it's the same thing that you did last year. Now, remember, a parabola has a vertex, which is the maximum or minimum point depending on which way it's drawn. If it's drawn down, it has a maximum point. If it's drawn up, it has a minimum point as its vertex. Right? Pretty simple. So, it also has an axis of symmetry. You should be able to fold it like a piece of paper, and it should overlap itself. Right? So it has an axis of symmetry. That axis of symmetry goes right through the vertex. There'll be a line we draw on there. It's a dotted line. And it shows that if I fold it right over that line, they should overlap. Right? They should be the same on both sides. So, it will always, always, always pass through the vertex. Now, parabolas have two forms. Like I said, there's a standard form and a vertex form. The first one written up there is standard form. Y equals ax squared plus bx plus c. When we go to determine if it opens up or down, we are looking at our a value here. The number in front of x squared. Okay. So if that a value, if that number in front of x squared is positive, then it opens up. It has a minimum point. If that a value is negative, it opens down. It has a maximum point. The way that I like to remember it is if it's positive, it smiles. It's a smiley face. If it's negative, it frowns. Opens down. Right? That's the way that I used to remember it. Do you need to use that way? Absolutely not, but if it helps you, it's awesome. So, that's the difference. That's how we can tell just by looking at our a value, looking at our equation, if it's going to open up or down. We'll also see it when we graph it, obviously. Okay? Cool? Questions so far? Okay. Then, talking about standard form, ax squared plus bx plus c equals our function. When we talk about a, b, and c are all constants. Right? What does that mean in math? What is a constant? So it's a number, right? It's 3, it's 7, it's negative 12. It's something that doesn't change. Right? So they're all constants. So a, b, c. A is the number in front of x squared. B is the number in front of x. C is that last number, that constant afterwards. Okay? Now, to find our axis of symmetry in our vertex, the axis of symmetry will always be the x value of your vertex. Right? No matter if we're using standard form or vertex form. It'll always be x equals whatever the x value of your vertex is. Alright? To find that x value, we're going to take x equals negative b over 2a. Now there's probably a reason I'm drawing about 300 circles around that. Because you're going to use it about 1,000,000 times, so make sure you know it. Right? So maybe put a circle around it, maybe star. That is a super important formula for this unit, for this part of our unit. So, that's to find the x value at our vertex. Right? A vertex is a point, it's got an x and a y. To find the x value, we do negative b over 2a. To find our y value then, to find the other part of our vertex, we're going to evaluate the function. Well, what does that mean? Put in something for x. What do you think that something is going to be? What we get out of here, right? So when we do negative b over 2a, that gives us our x value. We're going to take that, plug it back into the function to get the y value. Okay? Let's try it here. Let's try and find our vertex and our axis of symmetry. We have f of x equals x squared plus 4x minus 12. Remember our formula, ax squared plus bx plus c. Right? Now, I'm going to list A, B, and C for this problem. I will not do that normally. That is not something I normally do. If you want to do that to help yourself, you're more than welcome to. But I'm going to look here. The number in front of x squared is my A value. What number is that? 1. The number in front of my x is my B value. What number is that? 4. And then the last number here is my C, -12. Okay? Like I said, I will not normally list them. If that helps you, do that. So I want to find not only my axis of symmetry, but I want to find the x value for my vertex right now. What should I do?
That equation.
That equation we just circled. -b over 2a. X equals -b over 2a. Well, b is 4, so -4 over 2 times 1, which is my a value. Just plugging b and a into that formula. Well, what's 2 times 1?
1, 2.
2. What's -4 divided by 2? -2. So when I go to write my axis of symmetry, you must write it x equals -2. If you just put -2 there on the test, it's going to get marked wrong. I'll tell you that right now. Axis of symmetry is a line. It's a vertical line, so it needs an equation. If you just put -2, that's just one number, right? I need the x equals. It's an equation. Okay, then my vertex. The x value is going to be at -2. Well, how did we say we found our y value? Plug it back in. So, plug x into here. -2 squared plus 4 times -2 minus 12. Well, -2 squared is 4. 4 times -2 is -8. And then minus 12. 4 minus 8 is -4. Minus 12 is -16. Alright, just evaluating this. So my vertex then would be at -16. That is the most important point in your parabola or your quadratic equation. Because if that's not correct, nothing's going to be correct. Okay? Hey, if I ask you if this function here, if it opened up or down, what would you say?
Up would be the frown.
Ooh, how many people think up?
Wait, which one is up the frown?
Up is the smiley, right? The opening is up.
Oh.
Down is where the opening's down. How many people think it will open up or be a smiley face? How many people think it will open down? Why do you say it's going to open down, Natalie? Be careful though. Which value are we looking at, did we say?
1.
We're looking at the a value, which is +1. So if our a value is positive, right, we said when we are looking here, we said if our a value is positive, it will open up. If our a value is negative, it will open down. So this one, because a is +1, would open up like a smiley face. Alright? Okay. Any questions so far? That was standard form. Vertex form. The equation a times x minus h squared plus k. So, this one, it's called vertex form because they give us the vertex right in it. Right? If you look, this says the vertex is always the point h comma k. So that means I can look right at my equation, and I can take h, and I can take k, and that's my vertex. Then my axis of symmetry is x equals h, right? It's x equals whatever that x value is. Okay? So if I look at my example here, f of x equals x plus 5 squared minus 2. A times x minus h squared plus k. I want to know what my vertex is going to be. I want to know my h, my k. H comma k. Well, what's my h value going to be?
5.
Be very careful.
2.
If I put 5 into here for h,
K.
I get x minus 5. Is that what I have here? No, it's going to be -5.
What?
So here's a little trick to remember. The number inside here, we're always taking the opposite of. Because when you put it into this equation, it'll give you the opposite. Right? If I put 5 into x minus h, I get x minus 5. But I want x plus 5. Does that make sense? If I put negative 5 in here, I get x minus negative 5, which minus and negative would be plus 5. Does that make sense? If you're ever questioning if you picked the right h, what could you do? Plug it into here. See if you get what you have for an equation. So you're always taking the opposite of this number, and then for your k value, you are just taking the number that's out there. So in this case, it would be negative 2. So my vertex is at negative 5, negative 2. And then my axis of symmetry would be x equals negative 5. It's always x equals whatever that x value is for my vertex. Okay, does that make sense? Okay. Any questions so far?
Where does the A come in?
The A, in this problem, A is in front of the parentheses. So what would my A value be here? 1. So A is going to tell me, is that going to be open up or down? Up. It's positive, right? Now, are we good at this? Okay. Yeah, we will practice, right? Graphing the quadratic function. Step 1, you always start at your vertex. Always, always, always. You put your vertex on the graph, and you'll draw your axis of symmetry right through the vertex. That's step 1. Step 2, then, you're looking at your A value. See, is it going to open up or down? Now, if you use the shortcut method, I'm just going to talk about in a second. That's not the method I'm going to recommend. Then you definitely need to see if A opens up or down. If you use the other method, we won't really need that. We'll still see it. Okay? And then lastly, plot other points from the vertex. So, if you look at our graph of y equals x squared, right? X squared is just the basic quadratic function. It's our variable square. We said a quadratic has to have a square, right? So this is our basic quadratic function, our basic quadratic graph. If you look at the points on it, it'd be 0, 0, because I plug 0 in for x, I get 0 for y. 1, 1, because I plug 1 in for x, I get 1 for y. Negative 1, 1. Everything like that. It's just squaring the number I plug in. It's a parabola. Now, what happens is, as I go up by 1 for x, every time, my values change. I go up 1, up 3, up 5. Right? So our basic rule here, if you're using a shortcut, is if A equals 1, from your vertex you can go 1 to the right, 1 up. 1 to the right, 3 up. 1 to the right, 5 up. If A is 2, you just double how much you're going up. So instead of going up 1, I'm going 1 times 2, which is 2. If I'm going 3 up normally, I multiply it by whatever A is, I go up 6. I am not recommending you use the shortcut. I will show you another way to do it. I think it's much easier. It takes a little bit longer. It's not a shortcut, but I think it's easier to understand. Okay? If you want to use a shortcut, you can. I'm more than happy to work with you on it with your homework and other notes, but I'm going to show you a different way. Okay? All right. What time? I mean, just look. Like 27? That's done right? 29. Okay, we have almost 10, just over 10 minutes. Okay, so we're going to do 2 graphing problems. I think there's 4 on there. We're going to do 2 of them. 1 of each. 1 standard form, 1 vertex form. Okay? The first one's in standard form. Right? We notice x squared plus 4x minus 2. ax squared plus bx plus c. First thing I want to do is find the vertex. How do we say we find the vertex in standard form? Ange?
Negative b over c.
Negative b over
2a.
2a, right? X equals negative b over 2a. Well, what is my b value in this equation?
4.
4. So negative 4 over 2 times, what's my a value? 1. Hey, so if I was looking at this a value, it's positive 1, which way should my graph open?
Up.
Up. It's positive, right? Okay. Negative 4 over 2 gives me negative 2. So I have an x value of negative 2 for my vertex. Just pop that down here, it is. Negative 2. Okay? To find my y value, I'm plugging it back in for x. So negative 2 squared plus 4 times negative 2 minus 2. Does everyone understand that step? Okay? Negative 2 squared is 4. 4 times negative 2 is negative 8 minus 2. If I add those together, I should get negative 6. So my vertex should be at negative 2, negative 6. So that is the first point I'm plotting. Negative 2, 1, 2, 3, 4, 5, negative 6. What is my axis of symmetry then? What are you saying, Clark? Is that, you're telling me that's my axis of symmetry?
Negative 2 comma negative 6. Oh, x is equal to 2.
X equals negative 2, right? It's always x equals. It's a line, whatever my x value is. X equals negative 2. Now, this is really easy to draw. Watch this. You're going to draw a dashed line, and it's going to go straight up and down through your vertex. That's all it is. It's a dashed line straight up and down through your vertex. And now you've got your axis of symmetry. Okay? So we have 1 point currently. We have our vertex, right? You need 5 points on your graph. You need the vertex and 4 others. But realistically, we only need to find 2 because they mirror. Right? So let's do that. You can use the shortcut where you go 1 over, 1 up, 1 over 3 up, and plot those points. That's an easy way when a equals 1. When a is bigger than 1 or less than 1, it starts to get messy. Right?
It's like 2x squared.
If it was like 2x squared, then you'd have to multiply what you go up by 2.
Oh.
Okay? Now, I'm going to show you a different way. If I'm here, what is my x value? Negative 2. If I go here, then if I go 1 to the right, what is my x value? Negative 1. So I'm going to let x equal negative 1, and I'm going to plug it back in to find out what my y value would be. So I get negative 1 squared plus 4 times negative 1 minus 2. Negative 1 squared is positive 1. 4 times negative 1 is negative 4 minus 2. I should get negative 5. So at negative 1, negative 5, I should have my second point. Negative 1, negative 5. And when I get a point, guys, I can mirror it across my axis of symmetry. So I took the next x value to the right. You could use the one to the left. That's perfectly fine as well. I plugged it back in, and I found my y value. Once I plot that point, I mirror it across the axis of symmetry, and I now have 3 points. I need 2 more. Okay? Does that make sense what I just did? Alright, then I'm going to go 1 more to the right. What's my x value here? 0. And I'm going to plug that in. 0 squared plus 4 times 0 minus 2. 0 squared is 0. 4 times 0 is 0. I should get negative 2. So at 0, negative 2, I have another point. Mirror it across. Now I have 5 points. Now I can draw it in. Once you get above those 5 points, obviously your line should not cross, but just you draw them up and put arrows on the end. Yes, sir?
So basically for all you just kind of go to the right twice and then
Go to the right twice and mirror it across. Yep. If you use the shortcut, if you start at the vertex, you want to go 1 over 1 up, put a point, 1 over 1, 2, 3 up, and then mirror them across, you get the exact same points that we just did. The trick is when you start getting a values that are bigger than 1, how much you go up by changes. And that's where the shortcut confuses people. Okay, so that's why I show people this way. Do we have any questions?
Does it matter what number you plug in?
Like for x?
Yeah.
It does not. So if you want to use 5 or whatever, I mean, you're going to get a really big number. It might not be in your graph anymore. That's why I just use the next 2 over.
Okay.
You could go to the left. You could use negative 3 and negative 4. You get the same points and just mirror them across. Doesn't matter. Okay. Any other questions? Okay, let's do one more. We'll do it out of vertex form this time. Okay? So vertex form, f of x equals 2 times x plus 5 squared minus 2. Hey, notice, this is the same problem we did before. Isn't it? Right? No? Yes, it is. No, it's not. Is it? I don't know.
Because A is 2.
Oh, a is 2 in this one.
Yeah.
My bad. So a times x minus h squared plus k. But our vertex is going to be the same, right? If I look at my h value, it's still negative 5. If I look at my k value, it's still negative 2. Right? H is negative 5, k is negative 2. The opposite of what's in here, and whatever number's out here. So our vertex is negative 5, negative 2. Plot that point first. 1, 2, 3, 4, 5, 1, 2. What's my axis of symmetry then? X equals negative 5. Same thing. Find where your vertex is. A dashed horizontal line going straight through it. Vertical. Thank you. See, I mess up sometimes too. Okay. I'm going to do the same thing I did before. If I'm at x equals negative 5 and I go 1 to the right, I'm at x equals negative 4. I'm going to take that value and plug it into my equation to figure out my y value. Okay? So I'm going to get 2 times negative 4 plus 5 squared minus 2. I took the x value, 1 to the right, and I plugged it into here. Yes, sir?
But why is this still positive 5? Because isn't it x minus h?
I'm just using the equation that they give me. So, the original equation that we have for vertex form is x minus h, right?
Yeah.
So to find my vertex, I need to take the opposite of what's in here. Because if I plug in positive 5, I get x minus 5. Does that make sense? If you plug 5 in for h right here, what do you get from this part?
You get negative 4 minus 5.
Well, I'm not even worry about negative 4 right now. Let's just talk about finding the x value of the vertex, and then I'll get to what you were talking about, okay? If I plug positive 5 into h, what do I get?
X minus 5.
X minus 5. And I wanted x plus 5, right? So we took negative 5 for our vertex point, right?
But isn't it going to be positive anyway since it's squared?
What do you mean, the 5 is going to be positive?
After you do the equation in it. I don't know, like...
You're saying if we use minus or plus in there, they won't be the same though. Because negative 4 minus 5 will be negative 9. Negative 4 plus 5 will be positive 1. Right? So we are just using, when we're plugging x values in, we are using the equation we're given. Finding the vertex, we take the opposite of that number though.
The top equation doesn't matter at all, basically.
Only when we're finding the vertex, basically, okay? Okay, so I do this equation here. 2 times 1 squared minus 2. 1 squared is 1, times 2 is 2. I get 0. Right? All I do is the math here. Negative 4 plus 5 is 1. 1 squared is 1, times 2 is 2. Minus 2 is 0. Okay? So I'm at negative 4, 0. That's my first point. Negative 4, 0. And I mirror it across my axis of symmetry. Okay? Then I go one more to the right. I get x equals negative 3. I plug that in. 2 times negative 3 plus 5 squared minus 2. Negative 3 plus 5 gives me 2. So I get 2 times 2 squared minus 2. Well, 2 squared is 4 times 2 is 8. Minus 2 gives me 6. So at negative 3, 6, I should have my other point. Negative 3, 1, 2, 3, 4, 5, 6. Mirror it across and draw in your parabola or your quadratic equation. I'm going to say it. If you want to use the shortcut, right? Because some people probably want to use a shortcut. We normally go 1 over, 1 up, 1 over, 3 up, right? That's what we said? The shortcut, we take our a value, which is 2, let me do it in a different color, and we multiply how much we go up by our a value. So you would go 1 over 2 up, 1 over 6 up, 1 over 2 up, 1 over 6 up. We get the same points. Alright, so that's if you want to use the shortcut. I do not recommend it, but if you can handle that, then do it. Yes?
Where did you get the 6 from?
Down here?
Yeah.
So I got negative 3 plus 5 is 2. 2 squared is 4. Times 2 is 8. 4 times 2 is 8. Then minus 2 is 6. Okay. Swipe up, subscribe. Did I not? Oh, I did start. Okay.